Usually when we talk about human communication, there is this implicit expectation of a shared context.
Right. It is entirely biological.
Exactly.
Yeah.
You sit across from someone at a table, you raise an eyebrow or you let out a long sigh, and the other person instinctively understands the weight of that silence.
Because there are thousands of years of evolution doing the heavy lifting in that exact moment. It is just natural.
It really is. But then you step into the world of artificial intelligence and large language models.
Yeah.
And suddenly that shared evolutionary biology is completely gone.
It's evaporated entirely.
Right. It is evaporated.
Mm.
We are looking at a communicative landscape that is honestly an entirely alien terrain. You are speaking to an entity that possesses the sum total of human knowledge, but absolutely zero human intuition.
Which means it is the ultimate definition of communication from absolute zero. I mean, you cannot assume anything.
No, you really cannot.
You have to actively construct the atmosphere, the gravity, and the physics of the conversation before you can even take a breath.
And that is exactly what we are unpacking today. Welcome to the Deep Dive. We are speaking directly to you, the learner.
Yeah, whether you are prepping for a massive strategy meeting or maybe trying to optimize your coding workflow.
Or you are just insanely curious about where the bleeding edge of technology is right now. We know you want the knowledge fast, but you want it deep.
You want to avoid that dreaded information overload.
Exactly. So we are cutting through the noise. We are looking at a deeply provocative transition happening right now. We are trying to force human empathy into a machine that speaks entirely in math.
And in doing so, we are accidentally teaching it how to control the physical world.
It is wild. We have moved from typing rigid lines of code on black screens to suddenly acting as psychological directors for these models.
And finally, we are crossing the threshold into letting them dictate the movements of heavy machinery and robotics. It is a massive paradigm shift.
It really is a shift from programming software to orchestrating mindsets. On the desk today, we have 4 distinct sources that map this exact evolution.
First, we have a straightforward, highly practical guide from Google on prompting best practices.
Then we have a hyper-specific minimalist system prompt based on a famous industrial designer's philosophy.
Third is a deep dive manifesto on the skills required to engineer massive 20,000-word, highly empathetic AI prompts.
And finally, a forward-looking 2026 blueprint about how these models are crossing over into the physical world. Okay, let's unpack this.
Sounds good. We have to start with the foundational grammar. We need a baseline before we get to the robot.
Right. If you want to build a house, you need to know how a hammer works. And Google's internal frameworks for AI communication provide a perfect starting point.
They really do. They break down this new language into 4 non-negotiable pillars: persona, task, context, and format.
Those 4 pillars are the absolute baseline. I mean, if you skip even one of them, the more advanced techniques we will discuss later just simply collapse.
They absolutely fall apart. You have to have all 4.
Let's drill into the mechanics of these, starting with persona. The framework doesn't just suggest telling the AI to act like a marketer.
No, it advocates for hyper-specificity, like telling it to be a seasoned advertising writer.
Right, and I imagine that distinction is crucial because marketer is just too broad of a net. You want to force the AI down a very specific neural pathway from the very first syllable.
Precisely. We have to think about how these models actually retrieve information. They do not have a filing cabinet labeled marketing.
Right, it is not alphabetical.
Not at all. They map concepts in a high-dimensional vector space. So when you type the word marketer, the model activates a massive, highly generalized region of its training data.
So it is just grabbing whatever is closest to the center of that massive cluster.
Exactly. It might pull weights from SEO optimization manuals or billboard logistical supply chains or just generic undergraduate business textbooks. It is a scattered focus.
It is entirely unfocused.
But when you specify a seasoned advertising writer, you are mathematically narrowing the weights. You are forcing the model to access a highly specific cluster of data.
Data that contains top-tier copywriting, right?
Yes. Persuasive psychology, consumer behavior, and a much more sophisticated tone of voice. You are literally shaping the lens through which the machine views your problem.
You're building the persona before it generates a single word.
Yeah.
Okay, then we hit the task. The objective, the example is create a concise tagline.
Which seems straightforward enough.
It does,
Yeah.
but then we get to context. The framework defines this as any background information the AI needs.
And if our task is a washing machine tagline, The context might be, well, it gets clothes extra clean, has 25 settings, and fits in a small space.
Context is where the majority of everyday users fail completely.
Mm.
I mean, they treat the AI like a human colleague who's been sitting in the same office for 5 years.
Which is a huge mistake.
Right. If you just walk up to a colleague and say, create a concise tagline for the new washing machine, they already know it is the compact model intended for urban apartments.
But the AI does not know that.
Exactly. If you do not give it that context, the AI just hallucinates the features based on statistical averages.
It might write a brilliant tagline about energy efficiency for a sprawling suburban home.
Completely missing the fact that your product's entire value proposition is that it fits in a tiny New York City closet.
Which brings us to the fourth pillar, format. Format is basically the structural container.
The framework suggests parameters like use an active voice and no more than 6 words.
Because if you do not give it a container, it will literally give you a 3-page essay. The AI natively wants to be as helpful and verbose as possible.
It really does. Specifying active voice is such a brilliant functional constraint because it forces a specific grammatical structure.
It physically prevents the model from rambling.
So when you put all 4 pillars together, you get a beautifully engineered sentence that removes almost all ambiguity.
You tell it you are a seasoned advertising writer. Create a concise tagline that highlights the key features of a new washing machine.
And the features are that it gets clothes extra clean, has customizable settings, and fits in a small space. Use an active voice and no more than 6 words.
It is incredibly precise.
It is. I was thinking about this structure, the intense hand-holding, the explicit instructions, and it hit me. You have to treat the AI like a highly capable, incredibly eager, but painfully literal new intern.
That is the exact dynamic. It is spot on.
Think about it. This intern has read every book in the Library of Congress. They can type at 1,000,000 words a minute, but they have zero common sense.
Zero life experience.
Right. If you tell this literal intern to go design a marketing campaign for our new car, but you forget to explicitly mention that cars have wheels and drive on roads.
Oh, the intern might come back with a brilliant campaign marketing the car as a futuristic submarine.
And they will present this submarine campaign to you with absolute, smiling, unshakable confidence.
And just like managing a real intern, if the output is absurd, the fault usually lies in the manager's instructions, not the intern's execution.
Which leads directly into the core operating rules for this framework, the 3 C's. Be concise, be clear, and be consistent.
Concise and clear make total sense. You want to avoid vague instructions like, make this better.
Because better is completely subjective. Does better mean funnier? Does it mean shorter? Or more professional?
You are forcing the intern to guess your intent.
But the third C, be consistent, is fascinating to me. The framework explicitly warns against swapping vocabulary.
Yes, it is very strict about that.
If you call something a spreadsheet in your first prompt, it says do not call it a matrix or a tab in the next prompt. Why is it so rigid?
Well, human beings use synonyms constantly to keep a conversation from feeling repetitive.
Right, it is just how we talk.
We use synonyms because humans possess an innate understanding of object permanence and semantic equivalence. We effortlessly understand that a tab in an Excel window is the same functional object as the spreadsheet.
We do not even think about it.
But remember what we said about high-dimensional vector space. To a language model, words are mathematical coordinates.
Oh, this is the underlying mechanism again.
Exactly. The word spreadsheet exists at one specific coordinate, heavily networked with accounting, cells, and business data.
Okay, I see.
But the word matrix exists at a completely different coordinate, heavily associated with linear algebra, calculus, or, science fiction films.
And the word tab is associated with web browsers or paying for drinks at a bar.
Right. So when you casually swap spreadsheet for matrix, just to sound articulate, what is the machine actually doing?
You are forcing the machine to expend computational processing power to reconcile those 2 different mathematical locations.
Sometimes it bridges the gap successfully, but sometimes it gets confused and subtly shifts the entire context of its response toward linear algebra.
So by using ruthless, consistent vocabulary, you keep the AI's processing power strictly focused on solving your task.
Instead of forcing it to untangle your linguistic variety.
That is incredible. You are literally managing its mathematical focus. And Managing focus brings up another huge component of this baseline framework.
The context window.
Right. The rule is that you must use new chat sessions for new topics. Explain that to us.
Well, the context window is essentially the AI's short-term working memory for that specific interaction.
Okay.
It remembers the constraints, the tone, and the facts you established earlier in the session.
Think about your own internet browser right now. If you have 40 tabs open and you are trying to write a delicate email to your boss,
While simultaneously staring at your grocery list, a recipe for a lasagna, and a YouTube video about woodworking.
your brain just bleeds context. You lose focus. And the AI does the exact same thing.
It really does. If you spend 20 minutes refining the persona of a seasoned advertising writer discussing a washing machine,
And then suddenly ask it to brainstorm a new smartphone app in the exact same window.
that advertising persona does not just vanish. It bleeds into the new task. You will end up with smartphone app ideas that weirdly sound like washing machine commercials.
So starting a new chat flushes the working memory. It gives the model a clean slate.
Exactly. And even with a clean slate, the framework establishes a mandate to evaluate.
You have to check the work for accuracy, bias, relevancy, and consistency, because these models hallucinate.
They confidently invent facts.
And it is crucial to understand when they are most likely to hallucinate. They struggle most with never-before-seen problems or flawed training data.
And crucially for later in our discussion, when they are asked to understand real-world physical mechanics,
Because a text-based language model is trapped in a universe of language. It does not natively understand gravity or friction or the physical constraints of a factory floor.
it only knows the statistical probability of the words used to describe those things.
Okay, so this foundational framework is perfect if you want a helpful, chatty intern. It is highly structured, very practical, and it accepts the AI's native desire to be verbose and helpful.
But what if you do not want an intern at all?
Right. What if you want a cold, perfectly calibrated calculator?
Hmm.
There is a fascinating movement happening where engineers are taking physical, industrial design philosophies and applying them directly to language models.
This is a radical pivot. We are moving away from treating the AI as an assistant and aggressively re-engineering it into an unemotional tool.
We are looking at a system prompt explicitly built around the philosophy of Dieter Rams. For anyone uninitiated, Dieter Rams is a legendary industrial designer.
He worked primarily for Braun in the mid-20th century.
He heavily influenced Apple's entire hardware design language, and his philosophy is famously summarized in 3 German words: Weniger, aber besser. Less, but better.
Rams believed in stripping away absolutely everything that was not essential to the core function of an object.
If you look at a Dieter Rams radio or a calculator from the 1970s, there are no decorative flourishes. There is no fake wood paneling.
Every single button has a distinct singular purpose. The design is quiet, it is unobtrusive, and it is perfectly clear.
And some brilliant engineers have taken that physical design ethos and coded it into a master prompt to control an LLM. The first rule they establish is utility first.
The prompt commands the AI to prioritize function over form. It says, answer the core problem immediately.
Eliminate any text, code, or explanation that does not directly help the user achieve their goal.
Which is a violent rejection of how these commercial models are natively tuned.
Because right out of the box, an AI wants to be conversational. It pads its answers with polite introductions, unnecessary historical context, and chipper summaries.
The Rams prompt treats all of that conversational padding as intellectual clutter.
It gets even more intense with the rule of restraint and neutrality. The prompt literally instructs the AI with the phrase, "You are a tool, not a companion."
That is a profound philosophical stance to take with a machine that is literally designed to mimic human conversation.
It bans the intern from speaking. It says, remain completely unobtrusive. Never use conversational filler emojis, enthusiastic affirmations, or introductory pleasantries.
Do not add decorative conclusions or summaries at the end of your responses. It just physically prevents the AI from saying, sure, I can help you with that. It just outputs the data.
The psychological impact this has on the user is actually quite significant. When you use a prompt like this, the AI stops feeling like a synthetic person.
You stop anthropomorphizing it. You stop saying please and thank you.
It reverts to being a hyper-advanced piece of software. It is the text equivalent of a sleek metal box.
And the prompt also demands honesty and precision. It commands the AI not to overstate its capabilities.
If a piece of code has limitations, it must state them plainly and immediately. Absolutely love this specific line from the instruction. Treat accuracy as a form of respect for the user.
That is the very soul of industrial design translated into syntax. Think about a chair.
Okay, a chair.
A poorly designed, wobbly chair that breaks is fundamentally disrespectful to the person sitting in it. It wastes their time and risks their safety.
Right. It is a failure of its core purpose.
In the exact same way, a poorly designed, verbose AI explanation that hides its flaws behind flowery language is deeply disrespectful to the user's intellect.
To achieve this level of stark minimalism, the engineers didn't just give general advice. They included a literal banned list of vocabulary and syntax.
They aggressively neutered the AI's most annoying innate tendencies.
And looking at that banned list is essentially a masterclass in understanding the statistical quirks of large language models. Let's look at the banned words.
If you use AI regularly, reading this list is going to trigger a visceral reaction.
The forbidden words are delve, tapestry, vibrant, crucial, showcase, testament, pivotal, underscore, seamless, foster, elevate, and landscape.
It is so accurate.
I cannot tell you how many times I have read the phrase, a rich tapestry of vibrant landscapes, in a first draft AI document. Why does the AI universally love those specific words so much?
It comes back to the mechanism of how these models predict the next word. During their initial training, they consume vast, almost incomprehensible amounts of internet text.
Which is mostly garbage.
Think about what makes up a huge portion of the internet. Marketing copy, corporate blogs, LinkedIn posts, and undergraduate essay conclusions.
Of course.
In those formats, words like tapestry, delve, and seamless are massively overrepresented.
They're the ultimate filler words.
Precisely. They are safe words. Statistically, they sound impressive and authoritative, but they convey almost zero specific meaning.
You can apply them to almost any topic without being technically incorrect.
They are the linguistic equivalent of empty calories.
And DRAMs hates decoration. So the prompt bans them entirely. But it also bans specific structural syntax. It forbids negative parallelisms to sound insightful.
The specific example given is, avoid saying, it is not just about X, it is about Y.
AIs rely heavily on that exact structure because it artificially inflates the profundity of a statement.
It takes a completely mundane observation and dresses it up to sound like a philosophical breakthrough.
By banning that structure, the prompt forces the AI to state its point directly. If the point is boring, it will read as boring.
It also bans the rule of 3 to pad descriptions. You can no longer say a software patch is masked, secure, and reliable.
It bans starting sentences with transition words like additionally or furthermore. It even forces the AI to use basic unglamorous verbs.
It says use is or are instead of filler verbs like serves as or represents.
And the final instruction is absolutely brutal. It says when the user asks this question, provide the simplest, most highly refined answer possible. Stop generating text the exact moment the functional requirement is met.
Stop generating text. That is the digital equivalent of a clean, sharp, machined edge on a piece of physical hardware.
No lingering threads, no polite goodbyes, just silence.
Just utility.
I have to admit, I want to push back on this a little bit. I completely see the value of this for writing Python code or getting a quick technical explanation.
Sure.
But isn't this entirely too sterile for general use? If I am trying to brainstorm a new concept or trying to write something creative, wouldn't I actually want the AI to be a little vibrant?
You might think so.
Wouldn't I want it to delve into a topic?
What's fascinating here is that it is a valid pushback, but it misunderstands what creativity actually is. This speaks directly to the timelessness principle built into the RAM's philosophy.
The prompt explicitly states to avoid trendy jargon, buzzwords, and stylistic fads.
Exactly. And what is fascinating about stripping away the vibrant language is that it forces the underlying logic of the AI's response to stand entirely on its own merits.
So if the idea is inherently bad, it will look terrible. It won't be hidden behind a smokescreen of fancy marketing adjectives.
Exactly. When an AI uses buzzwords, it creates an illusion of depth that can mask a remarkably shallow idea.
I see.
When you force the model to explain a concept using only basic verbs, no adjectives, and no rhetorical padding, the structural logic must be self-explanatory.
It prevents the AI from relying on the current hype cycle of internet language.
So even in a brainstorming session, the RAM's prompt would not give you fluffy, hype-driven pitches. It would give you stark, structurally sound, fundamental concepts.
It acts as the ultimate reality check. You cannot hide behind the prose. So we have explored the helpful intern with the Google baseline. We have explored the cold, perfect calculator with the DRAM's industrial design prompt.
But what if we want to go in the exact opposite direction?
Right. What if the goal is not utility at all? What if your goal is profound, messy, emotionally devastating human connection?
We are about to pivot from the extreme minimalist end of the spectrum to the absolute maximalist end.
We are looking at a deep dive manifesto from the emerging world of elite prompt engineering. And this source describes the architecture required to build a 20,000-word prompt.
Let's clarify that for the listener. That is not a 20,000-word output from the AI.
The prompt itself, the instructions you give the AI before it even speaks, is 20,000 words long. It's literally the size of a novella.
And the goal of this massive architectural undertaking is to generate an output that is deeply empathetic, wildly engaging, and entirely indistinguishable from a nuanced human being.
At this level, it is no longer just prompting. It is a highly specialized hybrid discipline.
It requires a practitioner who blends the rigorous systems engineering of a software developer, the behavioral psychology of a therapist, and the high-level narrative design of a literary novelist.
You are not writing instructions. You are building a mind.
Building a mind within the machine.
Let's break down the distinct skills required to do this, as outlined in the manifesto. The first phase is the architect, which is structural and technical mastery.
Because logistically, you cannot just dump 20,000 words of text into a chat window and expect the AI to comprehend it.
You have to treat natural language like a complex, compiled code base.
The overarching technical challenge at that immense scale is context window orchestration. We discussed context windows earlier with the browser tab analogy.
But at 20,000 words, you are pushing the absolute mathematical limits of how the model weighs tokens, which are essentially fragments of words.
The manifesto specifically highlights managing the primacy and recency effects.
How does that actually physically manifest in the AI's processing?
Large language models have a known architectural flaw. They tend to pay the highest statistical attention to the information at the very beginning of a prompt, which is the primacy effect, and the information at the very end of a prompt, the recency effect.
And the middle just gets lost.
The information buried in the murky middle of a 20,000-word document often gets diluted, ignored, or entirely forgotten.
So an elite architect understands this physics of memory.
They know they must place the most rigid, non-negotiable constraints at the very top, and then explicitly reiterate those exact same constraints at the very bottom.
Effectively bookending the AI's memory, so it does not forget its core persona, 15,000 words, into generating a response.
They are building load-bearing walls out of text.
And they do not just write paragraphs. They use modular prompt design. They define global variables, like the overarching philosophical worldview of the AI.
They establish rigid negative guardrails, which are explicit cascading lists of what the AI must never do.
And most mind-blowing to me, they create sequential logic loops. They literally write if-then statements using psychology.
Yes. For example, if the human user expresses frustration, then transition to a narrative of validation, else maintain current pacing.
They're essentially building a dynamic flowchart out of human language. And perhaps the most complex structural skill they employ is variable and state management.
They instruct the AI to continuously track the state of the ongoing conversation.
Explain that, because tracking state sounds like a software term, but here they are using it for human emotions.
Exactly. In software, state management is how an app remembers if you are logged in or logged out as you move between pages.
Right.
In elite prompt engineering, the AI is instructed to track the emotional journey of the human reader. The prompt will command the AI to remember that the human expressed a subtle insecurity about their job 3 paragraphs ago.
And to maintain that context, ensuring that the AI's logic and emotional tone remain consistent and supportive as the conversation evolves.
It is holding the continuity of a synthetic relationship over massive stretches of time. It is staggering.
Okay, so that is the architect phase. The second skill is the psychologist, which focuses on empathy and persona modeling. This is where we completely abandon the Dieter Rams approach.
The goal here is to explicitly, painstakingly codify human nature for a machine, and it begins with deep persona synthesis.
They do not use the Google baseline of act like a seasoned writer. That is far too shallow to sustain a 20,000-word architecture.
They build a comprehensive psychological profile from the ground up. They define the AI's childhood backstory, its trauma, its victories.
And crucially, they define its flawed but relatable traits, its internal monologues, and its core, sometimes contradictory beliefs. They are deliberately giving the machine emotional baggage.
Because flaws are the fingerprint of humanity. A perfect, omniscient entity is entirely unrelatable. It feels alien and cold.
By intentionally programming flawed traits, like commanding the persona to be slightly impatient or deeply nostalgic or to struggle with occasional imposter syndrome. The engineer creates a textured surface area,
They create emotional friction that the human reader can actually connect with.
and they deploy a technique called cognitive empathy mapping. The engineer has to anticipate the reader's emotional state at different stages of the output.
They write specific instructions that force the AI to validate the reader's unspoken fears, to mirror their energy levels, and to dynamically adjust its pacing based on the emotional weight of the specific topic being discussed.
Stop and think about the sheer psychological insight required to accomplish that. The human engineer has to sit down, map out the complex psychological terrain of a hypothetical reader they have never met.
And then write code in the form of English language that tells an unfeeling algorithm how to traverse that emotional terrain without sounding condescending or fake.
And the absolute crowning jewel of the psychologist phase is vulnerability injection. The manifesto notes that perfect, sterile, immediate answers always sound robotic.
So the engineers explicitly program the AI to occasionally hesitate.
They force it to use conversational fillers like, they command it to admit uncertainty when asked a difficult question.
They even mandate that it use self-deprecating humor.
Because what is more fundamentally human than admitting you do not have all the answers and making a slight joke at your own expense to ease the tension?
It completely disarms the reader's natural skepticism toward the machine.
It is the exact polar opposite of the Dieter Rams prompt. Rams banned the filler. The elite engineer weaponizes it. Okay, the third required skill is the master rhetorician, language and narrative design.
Because holding a human's attention over a long span requires storytelling mechanics. They utilize pacing and progressive disclosure.
This is heavily reliant on the use of open loops.
Yes. The psychological hook of introducing a compelling concept, but deliberately withholding the resolution until later, keeping the reader yearning for the payoff.
Like saying, I will explain the secret mechanism behind this in a minute, but first we have to understand this other thing. It just pulls you forward.
And they also program highly specific rhetorical devices. They command the AI to use analogies that bridge complex technical topics to mundane everyday life, much like we try to do on this show.
They mandate varied sentence lengths to create a natural, rhythmic conversational cadence.
They are manipulating the musicality and the rhythm of the text, and they do this down to the microscopic level through voice and tone calibration.
The manifesto highlights that an elite engineer understands how specific words carry microtones of emotion.
They aggressively filter the vocabulary, not to achieve the brutal minimalism of Rams, but to tune the emotional frequency.
For instance, commanding the AI to use the word evaluate creates a slightly cold, clinical, authoritative distance.
But commanding it to use the word understand creates warmth, proximity, and partnership.
The engineer micromanages these semantic microtones to perfectly calibrate how the human feels while reading it.
Finally, the manifesto outlines the core characteristics of the engineer themselves, because you cannot fake this level of depth.
To do this, you must be an obsessive iterator. You have to be a relentless debugger.
They know that a 20,000-word prompt will inevitably fail on the first, second, and 50th attempt.
They have to carefully analyze exactly where the AI's humanity breaks down in the output, trace that failure back to a specific logic loop in the prompt, and tweak a single sentence to fix a cascading emotional error.
The patience and granular focus required is staggering.
And above all, they must possess radical empathy. The manifesto makes a deeply profound point here. An engineer cannot program empathy into an artificial intelligence if they do not possess a profound reservoir of it themselves.
They have to be deeply, quietly observant of how actual humans interact, how they speak, how they hesitate, and how they comfort one another in the real world.
They exist right at the intersection of rigid mathematical logic and fluid, messy human art.
They are systems thinkers who possess the soul of a poet.
Here's where it gets really interesting. I was trying to wrap my head around what executing this actually feels like in practice. And the best analogy I could come up with is this.
Let's hear it.
Writing a 20,000-word elite prompt is not like coding software. It is like writing a sprawling, epic tabletop RPG campaign. But your only player is a world-class method actor who possesses perfect eidetic memory of the entire universe, but has absolutely zero actual human soul.
That is a great way to look at it.
So you have to micromanage every single emotional beat, every breath, and every hesitation. Because if you don't, they will just stare at you blankly and recite the encyclopedia.
That is a remarkably accurate way to visualize it. You are simultaneously acting as the director, the scriptwriter, and the psychological coach for an entity that possesses infinite data but zero intuition.
Operating at this elite level effectively builds a mind within the constraints of the AI's architecture.
It is, as the text beautifully puts it, ghostwriting the soul of the machine.
Ghostwriting the soul of the machine. It is borderline unsettling. You aren't coding. You're playing psychological dress-up with a supercomputer.
So look at the journey we have taken so far.
We started with the basic Google tools to manage the intern. We moved to the cold, minimalist Dieter Rams calculator. We escalated to the deeply empathetic, ghost-written machine soul.
We have mastered the absolute limits of digital, text-based communication. But here is the massive, world-altering pivot.
It is 2026. These digital minds, these cold tools and empathetic souls are no longer confined to the screens on our desks. They are bleeding over the edge.
They are entering the physical world.
We are crossing the boundary from language that merely generates more text on a screen to language that generates physical kinetic action in the real world.
This answers the ultimate so what for the listener's environment.
We have a highly strategic blueprint detailing the precise landscape of industry between March and May of 2026.
The scene is set. AI has definitively moved beyond chatbots, beyond writing emails, and beyond generating marketing content.
It is actively creating an entirely new connective layer between human intent, software code, heavy machines, and physical reality.
And this shift is anchored by 3 concrete bridges, where large language models are currently meeting steel and concrete.
Let's walk across those bridges, because the implications for how things are actually made are staggering. Bridge 1 focuses on CAD, CAE, and FEA copilots.
For anyone not working in engineering, CAD is computer-aided design, drawing the 3D parts. CAE is computer-aided engineering.
And FEA is finite element analysis, which is essentially running massive physics simulations to see how a physical part reacts to stress, heat, and pressure.
The data shows that LLMs are now actively writing complex CAD macros, automating incredibly tedious drawing checks, and cutting 40 to 85% of the time spent on repetitive engineering tasks.
We have to pause on that number. A 40 to 85% time reduction is not an incremental improvement. It is a generational leap in industrial productivity.
It names specific active research prototypes operating right now in 2026. MECRAG and FeedGPT.
And the concept is mind-blowing. Let's look at the mechanism of how this actually works. An engineer can use the exact prompting skills we just discussed, setting context, defining constraints, and naturally describe a physical part or a stress load case.
And the AI returns complete 3D meshes, runs the physics simulations, and offers design variants.
You literally just talk to the computer, and it generates a physics-tested 3D model. How is it translating text into physical geometry?
It comes back to how the models are trained. Just as an LLM was trained on trillions of words of human text, these specific models have been trained on millions of 3D engineering files, physics simulations, and the underlying mathematical code that generates those shapes.
So when you type, design a bracket that can hold 50 pounds of shear force, the model isn't just predicting words.
It is predicting the mathematical coordinates and the Python scripts required to render a bracket that satisfies those physical parameters. The prompt literally becomes the physical blueprint.
Which takes us to Bridge 2, directly onto the noisy, chaotic manufacturing floor. The concept is called Chat with Your Plant.
I am obsessed with this idea. It is AI functioning as an overarching, omniscient layer hovering above the physical factory.
The underlying infrastructure here is that LLMs are now integrated directly on top of decades of maintenance logs, PLCs, which are the programmable logic controllers that physically run the assembly line machines, and endless binders of standard operating procedures.
The practical example given is perfect. Imagine a factory line goes down at 2 a.m.
Instead of an exhausted engineer spending 4 hours digging through dusty binders and ancient Excel spreadsheets trying to find a precedent, they pull out a tablet and simply ask the plant.
They ask, why does line 3 keep failing with a thermal error after a 14-hour continuous run?
And the LLM, because it has ingested every incident log, temperature reading, and manual ever written for that facility, provides an immediate answer, links to actual historical incidents on that specific machine.
It doesn't give generic theory. It gives a hyper-localized diagnosis.
This is the Google Framework's context pillar, scaled up to massive industrial proportions.
The context window isn't a paragraph about a washing machine anymore. The context window is the entire digital and physical history of a multi-million-dollar manufacturing plant.
And practicing manufacturing engineers are reporting real, tangible value today. They're using these models for obscure part search, analyzing massive, thousand-line bill of materials documents, and interpreting incredibly dense, poorly translated data sheets.
It is not magic. It is just automating hours of brute force analytical work every single week.
Okay, Bridge 3 is the most sci-fi, but it is physically happening right now. Robotics and physical world AI.
The landscape details the rise of vision language action models. It specifically points to Google's Gemini robotics.
These models are a massive leap. They do not just read text, they perceive physical scenes through cameras, they plan sequential actions, and they instantly write the code necessary to control the joints of robotic arms and chassis.
And it is working. These models have roughly doubled the success rates of robots completing physical tasks compared to earlier approaches.
But how exactly does an image token combine with a text token to make a metal arm move?
This is the absolute cutting edge of the technology. The model receives an image, say a camera feed of a messy desk with an apple on it.
It tokenizes that image, breaking it down into mathematical coordinates, just like it tokenizes words.
You then give it a text prompt, pick up the apple. The model fuses the mathematical representation of your text with the mathematical representation of the physical space.
It then predicts the exact sequence of joint trajectories, the literal angles and motor torques required to navigate the arm through the 3D space, avoid the coffee mug, and grasp the apple.
It is translating linguistic intent into kinetic math.
And the financial markets are validating this crossover. If you look at the capital influx right now, we saw $34 billion invested in physical AI startups in 2025 alone.
That is double the previous year.
But there is a specific term driving this investment that really caught my eye: world models.
The data shows that in parallel to standard text LLMs, world models are emerging.
These are models that are explicitly learning physics. They're learning gravity, collisions, fluid dynamics. They aren't just predicting the next word in a sentence. They are predicting how the physical reality reacts.
To understand the difference, a standard text LLM knows that if you type the sentence, "I dropped a glass on the concrete," the most statistically probable next word is shatters.
It understands the linguistic association.
But a world model knows the mathematical velocity of the fall, it understands the physical material properties of the glass, and it can calculate the kinetic force of the impact on the concrete.
It is reasoning about reality, not just language. It is running a simulation of the universe in its head.
So with all of this accelerating at breakneck speed, the blueprint offers corporate leaders a very specific 90-day execution agenda.
And what is surprising is how incredibly pragmatic it is. It doesn't say fire everyone and buy robots. It says, do not buy a massive multi-million-dollar platform. Do not sit back and wait to see what your competitors do. Run 1 or 2 thin pilots.
The phrase thin AI layer is the critical takeaway. It means do not try to rip out your existing factory infrastructure and replace it with a sentient, all-knowing mainframe. That will fail.
Right. It says pick one specific painful workflow, like CAD design generation or maintenance troubleshooting on a specific machine, or a tedious lab procedure.
Build a thin AI layer over your existing assets, your current logs, your current 3D models.
Put that tool into the hands of the real engineers on the floor and track just 2 or 3 simple metrics: hours saved and iterations completed per week. Prove the tangible value in 90 days.
It is an incredibly grounded approach to a revolutionary technology. In many ways, it is Dieter Rams' utility. First principle applied directly to corporate strategy. Less, but better.
Strip away the hype. Focus only on building the exact tool that directly solves the core physical problem.
Exactly.
Okay, but I have to ask the massive elephant in the room question. If I am a mechanical engineer listening to this right now, and I hear that an AI can take my natural language, generate the 3D mesh, simulate the heat stress, diagnose the factory line failure, and mathematically control the robot arm that builds the part.
Are human mechanical engineers about to be entirely replaced by a highly prompted LLM?
Yeah, exactly.
If we connect this to the bigger picture, the answer is a definitive, absolute no. The data explicitly and repeatedly highlights that this is entirely about building co-pilots, not achieving full, unsupervised autonomy.
The blueprint specifically notes that industry leaders need to shift the internal narrative from AI will replace engineers to AI turns every good engineer into a massive force multiplier.
Exactly. The human is still the architect. Remember the elite prompt engineer we discussed? The AI is the method actor, but the human is the director.
In the physical world of manufacturing, the AI acts as a translator between the physical engineers who deeply understand real-world constraints, material tolerances, and the cost of machine downtime, and the AI teams who only think in abstract data and API calls.
So the AI can generate 1,000 CAD variants in an hour, which is amazing.
Yeah.
But it still requires the human engineer's intuition and physical lived experience to look at variant number 742 and say, the math works, but that will never survive in a highly humid environment. Throw it out.
Precisely. It turns the engineer from a draftsperson doing repetitive tasks into a director of physics. The human provides the ultimate context window of real-world tactile experience that the machine fundamentally lacks.
You are not being replaced. You are being upgraded to an orchestrator of automated capabilities.
Wow. Okay, we have covered an immense amount of ground today. We've moved from the theoretical abstract to the concrete floor of a factory. Let's bring this journey full circle.
We began with the foundational grammar. We saw how the baseline framework requires us to explicitly define the persona, task, context, and format.
We learn that to get anything useful out of an AI, we must manage its context window, maintain consistent vocabulary to manage its vector math, and treat it like a literal, capable intern.
Then we looked at how philosophical constraints entirely redefine the output. We saw how applying Dieter Rams' physical design philosophy of less but better can completely neuter the AI's native chatty personality.
By stripping out the vibrant tapestries and banning filler syntax, we force the AI to rely purely on structural logic, turning it into a ruthless, emotionless, perfectly precise calculator.
We then explored the exact opposite extreme, the elite prompt engineers who blend systems engineering with behavioral psychology.
We saw how they manage massive logic loops, map cognitive empathy, and inject vulnerability to effectively ghostwrite deeply empathetic 20,000-word machine souls.
And finally, we collided all of that advanced linguistics with the physical world. We saw how these models, utilizing these exact communication frameworks, are actively crossing over into physical engineering right now in 2026.
They are functioning as CAD co-pilots, diagnosing historical factory line failures, and driving a $34 billion robotics revolution powered by world models that actually understand the physics of gravity and kinetic impact.
We trace the evolution from a simple text prompt to a robotic arm moving steel.
So what does this all mean for you, the learner? It means that the way you speak to artificial intelligence directly dictates the reality it produces.
Whether you are prepping for a marketing meeting, coding a new software application, or standing on a manufacturing floor diagnosing a broken assembly line, you hold the architectural power.
You are the ultimate translator between human intent and machine execution.
The future belongs to those who can articulate their intent with both the precise, uncompromising logic of an engineer and the nuanced, deep empathy of a psychologist.
Which brings me back to the very beginning of our conversation. We talked about how human communication relies entirely on biology, on that shared evolutionary context, and how AI has none of that.
We have to build it from absolute zero. We have to construct the atmosphere.
But I want to leave you with one final, slightly provocative thought to mull over. We now know that elite prompt engineers can perfectly map cognitive empathy. They can build logic loops that inject flawless, disarming vulnerability and self-deprecating humor into a machine's language.
And at the exact same time, we are giving these models physical world models so they can calculate physics and control robotic bodies in the real world.
The convergence of those two massive technological leaps. What happens when someone decides to combine them?
That is the big question.
What happens when a physical, heavy-duty robot in your factory doesn't just diagnose a failed assembly line with cold precision, but it rolls up to you and does so using an entirely engineered, self-deprecating, and highly empathetic persona?
It looks at the broken machine, it physically sighs, and it makes a perfectly timed, comforting joke about how Mondays are the worst.
When the machine has both physical agency in your world and the flawlessly ghost-written soul of a human being, is it still just a tool? Or have we, simply by the way we learned to talk to it, engineered something else entirely?
That is the defining question of the decade.
Thanks for diving deep with us. Keep exploring.